Hi, welcome to this Corbettmaths video. In this video we're going to look at the video solutions to the Corbettmaths practice questions on product of primes and also finding the LCM and the HCF using product of primes. So finding the lowest common multiple and the highest common factor using product of primes. If you need any extra help on those topics, if you go to Corbettmaths and go to the videos and worksheet section and scroll down to video numbers 223 and 224, there's dedicated video tutorials there for those. Alternatively, you can scan this QR code. But in this video we're going to focus on the video solutions to the practice questions, so let's get started. Okay, so let's have a look at our first question, question number 1. So question number 1 says express 36 as a product of its prime factors. So we want to write 36 as a product of prime factors, so we want to write it as a product of primes. So there's a few different ways we could do this. One approach is to use the upside down Bush Shelton method. So some people do this where they write 36 and then they say, well, we can divide that by 2 because that's a prime number. So we could divide by 2. That would give us 18. Then we could divide by 2 again. Then that would be equal to 9. We could divide by 3. That would be equal to 3. And then finally, we could divide by 3 again. And then we get to 1. And that means we're done. So that means that 36 as a product of primes would be 2 times 2 times 3 times 3. So that'll be 2 times 2 times 3 times 3. Or you could write that as 2 squared multiplied by 3 squared, write it in an index form. Now this question actually didn't ask us to write it in index form, so you could just leave it as 2 times 2 times 3 times 3, or you could write it in index form if you wanted to and write 2 squared times 3 squared. So that's how you would do that question using this method, where you use this upside down Bush Shelton method, and if you want to do that, feel free to. Now another approach is to use a prime factor tree, so we could start off with 36 and say, well, let's find two numbers that multiply together to be 36. Don't use 1 and 36. So I'm going to try 2 and 18. 2's prime, so let's circle it, and then we're left with 18. 18, well, that's 2 times 9. 2 times 9 is equal to 18. Now, you could have gone for 3 times 6. It doesn't really matter. You're going to circle all the prime numbers at the end anyway. So 2 times 9 is equal to 18, so circle the 2, it's prime. 9's not. It would be equal to 3 times 3. So as you can see here, we've got 2, 3 and 3 all circled. So that means that 2 times 2 times 3 times 3 is also equal to 36. So 36 would be equal to 2 times 2 times 3 times 3. And that's it. So 36 is a product of prime factors. You could write it in this form, 2 times 2 times 3 times 3, or you could write it as 2 squared times 3 squared, just write it in index form. And this question didn't ask us to write an index form, but that's how I've written the answer there. As I said, you could write it as 2 times 2 times 3 times 3, and that's it. So this question, we've actually approached it in two different ways. One way is to use the upside down Bush Shelton method, so like this, and if you use that approach, that's fantastic. Another approach is to use a prime factor tree, so this approach here, and if you use that, that's fantastic too. Now for the rest of this video, rather than doing each of these questions using two different methods, I'm just going to use one of them. I'm just going to use the prime factor tree approach, but if you use this approach, that's totally fine as well. Okay, let's have a look at our next question, question number 2. So question number 2 says to express 100 as a product of its prime factors. So let's start off with 100, and we're going to think of two numbers that multiply together to be 100. So I'm going to go for 10 times 10. 10 times 10 is 100. So neither of these are prime, so now let's look at this first 10. Well, 10 will be 2 times 5, and 2 and 5 are both prime, so let's circle them both. Now we've got another 10 here, so that would be 2 times 5 as well, so 2 times 5. So that means that 100 would be equal to 2 times 5 times 2 times 5. I like to do it in order. I like to do 2 times 2 times 5 times 5. So 100 would be equal to 2 times 2 times 5 times 5. And that's it. So we've written 100 as a product of its prime factors, 2 times 2 times 5 times 5. So we could write it like that. I like to write it in index form, so I'm going to write 2 squared multiplied by 5 squared, because we've got 2 squared times 5 squared. And that's it. Okay, let's look at our next question, question number 3. So question number 3 says, write 42 as a product of its prime factors. So we want to write 42 as a product of primes. So let's set up with our 42, and we're going to do a prime factor tree. And remember, if you'd like to use that upside down Bush Shelton method, feel free to use that. So 42, I'm going to go for 2 and 21. 2's prime, so let's circle it. 21's not, that's equal to 3 times 7, and they're both prime. So that means that 42 would be equal to 2 times 3 times 7, and that's it, 2 times 3 times 7. And we don't need to worry about writing that one in index form because it's just 2 times 3 times 7, and that's it. Okay, let's look at our next question, question number 4. Okay, so question number 4, we've been asked to write 24 as a product of prime factors and to give our answer in index form. And quite often questions will ask you to do that. So let's start off with 24 and let's do our prime factor tree. So I'm going to go for 2 times 12. 2's prime, so let's circle it. 12, let's go for 2 and 6. 2's prime, let's circle it. 6 isn't, so that's going to be 2 times 3. So So let's circle the 2 and the 3. So that means that 24 is equal to 2 times 2 times 2 times 3. And actually, you just want to mention that you can actually check your answer. If you do 2 times 2, that's 4, times 2 is 8, times 3 is 24. So you can check your answer as well. If you just check that whenever you multiply those prime numbers together, you get the number you're meant to write as a product of primes, then you know you're right. So 24 is equal to, and let's just write them in order, 2 times 2 times 2 times 3. So 2 times 2 times 2 times 3. And let's write it in index form. So we've got 2 times 2 times 2. There's 3 2's multiplied together, so that's going to be 2 cubed, because there's 3 of them, multiplied by 3. So the answer would be 2 cubed multiplied by 3, and it's in index form. So that's it. Fantastic. Okay, let's look at our next question, question number 4. So question number 4, we've been asked to write 360 as a product of its prime factors. So let's start off with 360. So we've got 360. And let's think of two numbers that multiply together to be 360. I'm going to go for 2 and 180, because half of 360 is 180. So 2 is prime, let's circle it. 180 is not, it ends in a 0, so we know it's a multiple of 10. So now let's go for, well, let's do 10 and 18. Neither of those two numbers are prime, so let's look at the 10. So 10 would be 2 times 5, and they're both prime, so let's circle them, 2 and 5. 18, let's go for 3 times 6 is 18. The 3 is prime, let's circle that, but 6 isn't. So this is quite a big tree whenever we're doing this one. Remember, you can use those upside down bookshelf methods, but I'm just using the tree here. And 6, I'm going to go for 2 times 3. So let's circle those. So we've got 2 times 2 times 5 times 3 times 2 times 3. And let's just check this. 2 times 2 is 4, times 5 is 20, times 3 is 60, times 2 is 120, times 3 is 360. So that's fantastic. Now we want to write this as a product of primes. I like to write these in order. So 360 would be equal to 2 times 2 times 2, so 2 times 2 times 2, and let's just make sure we've got them all, 1, 2, 3, 1, 2, 3, yep. Then in terms of the 3's, we've got 2 of those, so times 3 times 3, and then we've just got a 5 there, so times 5. So that means that 360 is equal to 2 times 2 times 2 times 3 times 3 times 5. It didn't ask us to write it in index form, so we could just leave it like that if we wanted to, but I'm going to write it as 2 cubed, because we've got 3 2's multiplied together, so that's 2 cubed, multiplied by 3 squared, so 3 squared multiplied by 5. And that's our answer, 2 cubed multiplied by 3 squared multiplied by 5. And that's it. We've written 320 as a product of its prime factors. Okay, let's look at our next question, question number 6. So question number 6 says to write 5,760 as a product of its prime factors, and to give your answer in index form. Now this question is a calculator question unlike the others, and you can actually use your calculator to write numbers as a product of the prime factors. So let's have a look at how do we do that now. Okay, so it's a calculator question, so I've got two calculators here. Okay, so I'm going to start off with this one, and if I wanted to write 5,760 as a product of primes using this calculator, the first thing I would do is type in the number, 5,760, and then press equals, or exe, and as you can see there, it's on the display. Now what I'm going to do is I'm going to press the format button, and when I press the format button, I've got some options here. I've got standard, decimal, prime factor, that third one down. And if I press down and down, and press equals, or exe again, I get 2 to the power of 7 multiplied by 3 squared multiplied by 5. So that's it, that's 5,760 as a product of its prime factors. 2 to the power of 7 times 3 squared times 5, and that's it. Okay, let's have a look at another calculator. Now this one's slightly different than the other one, it's a bit of an older model, so I'm going to type in 5,760 and press equals again. Now this time there's no format button, but you've got here in yellow, fact, F-A-C-T, fact. If we press shift and then press that button there, you can see you get the same answer, 2 to the power of 7 multiplied by 3 squared multiplied by 5, and that's it. And as we've seen, the answer would be 2 to the power of 7 multiplied by 3 squared multiplied by 5. And that's it. So it can be quite useful to be able to use your calculator to write numbers as a product of primes. So rather than having to do it manually for a number such as this number, it'd be much easier to use your calculator. And sometimes in a calculator test, you can do that. Okay, let's look at our next question, question number 7. Okay, let's look at our next question, question number 7. So question number 7 says a number is written as the product of prime factors as 2 multiplied by 3 squared multiplied by 5. And we've been asked to work out the number. Now we've actually looked at how we did this earlier on in the video. I said that whenever you wrote a number as a product of primes, you can check you're right by multiplying those primes together, and if you get the number you started with, then you're right. So if we just work this out, we'll find out what the number was. So we need to do 2 multiplied by 3 squared multiplied by 5. Now remember our order of operations, we need to do any squaring before we do any multiplication. So we're going to do 3 squared first of all. So 3 squared, 3 times 3 is 9. So we've got 2 times 9 times 5. I've just worked out 3 squared. because we've got to do an order of operations. We've got to do the powers first. Now let's do a multiplication. We could do 2 times 9, which is 18, and then times by 5. I'm actually going to do 2 times 5 first of all. So 2 times 5 is 10, and times 9 would be 90. So that means the number is equal to 90. So here we just done 2 times 5 is 10, and then times by 9. Remember, whenever you're multiplying numbers like this, the order is not actually important. You could do 2 times 9, and then times by 5. You could do 5 times 9 is 45, and then times by 2 is 90. Or you could do 2 times 5 is 10, times 9 is 90 as well. So the number is 90, and that's it. Okay, let's look at our next question, question number 8. So question number 8 is a calculator question, and it says, given that 18,000 is equal to 2 to the power of A multiplied by 3 to the power of B multiplied by 5 to the power of C, we've been asked to work out the values of A, B, and C. So it's a calculator question. So let's just use our calculator to work out what 18,000 is as a product of primes. And it's 18,000, so I'm going to type that in, 18,000, so 18,000. Press equals or exe there, and as you can see we've got 18,000 on the calculator display. Then we want to get it as product of its prime factor, so let's press format, and as you can see the third one down is prime factor. If we press down and down and then exe again, we've got 2 to the power of 4 multiplied by 3 squared multiplied by 5 cubed. So that means that A is equal to 4, B is equal to 2, and C is equal to 3, and that's it. So as we've seen, 18,000 is equal to 2 to the power of 4 multiplied by 3 to the power of 2 multiplied by 5 to the power of 3, or 2 to the power of 4 multiplied by 3 squared multiplied by 5 cubed. And we've been asked to work out the values of A, B, and C. So A is the power for 2, so that's going to be 4. B is the power that 3 is raised to, which is 2. And finally C is this number, the power for the 5, which is 3. So A is equal to 4, B is equal to 2, and C is equal to 3. And that's it. Okay, let's look at our next question, question number 9. So question number 9, we've been given that 3x squared is equal to 75, where x is a prime number, and we've been asked to find the value of x. So a few different approaches we could use here. We could actually solve the second equation, so divide both sides by 3 to begin with, to get that x squared is equal to 25. And then because you know that x is a square number, if you square root the 25, you get that's equal to 5, so you know that x is equal to 5. Another way to look at it is, well, if we've got 3, which is a prime number, and you multiply it by x squared, which is a prime number squared, that means that we've got a prime number times a prime number times a prime number. So that means that these are all prime numbers. So we're writing 75 as a product of primes. So let's actually just write 75 as a product of primes. So we could do 75. Well, it's in the 5 times tables because it ends in a 5. So that would be 5 times 15. 5's prime, so let's circle it. And 15 would be, well, 3 times 5 is equal to 15. So we've got the 75 is equal to 5 times 3 times 5, or 3 times 5 times 5. So that means that x is equal to 5 because it's 3 times 5 squared. So x is equal to 5. And that's it. So you could solve it by writing 75 as a product of primes because you know this is a prime number and that's a prime number squared. Or you could solve like an equation. So if you had an equation like this, you could divide both sides by 3, divide the left hand side by 3 and the right hand side by 3. On the left hand side you had 3 times x squared. You divide them by 3 to get rid of the times by 3, so you just be left with x squared is equal to, and 75 divided by 3 would be 25. And then we've got a number squared is equal to 25, so it could be either 5 or minus 5, but we're told that x is a prime number, so that means that x would be equal to 5. So that means x is 5. Okay, now in terms of part B says write 75 as a product of primes. So we've actually done that already because 75 is 5 times 3 times 5. So 75, let's put them in order. 3 times 5 times 5, so 3 times 5 times 5. Or in index form, that would be 3 times, and we've got 5 times 5, that's 5 squared. So as a product of primes, 75 is 3 times 5 squared, and that's it. We've written 75 as a product of its prime factors, and that's it. Okay, let's look at our next question, question number 10. Okay, let's look at our next question, question number 10. So question number 10 is a similar question. We've been given that 3 times x cubed is equal to 375, and we're told that x is a prime number. So again, we've got 3, which is a prime number, multiplied by a prime number cubed. So that's a product of primes. You've got a prime times a prime times a prime times a prime, and then that would be 375. Okay, so we've been asked to find the value for x, so we could use it to a few different approaches here. One approach is to solve like an equation. 3x cubed is equal to 375. You could divide both sides by 3, so divide the left hand side by 3 and the right hand side by 3. And on the left hand side, we're dividing by 3 to get rid of the times by 3, so we're left with x cubed. And on the right hand side, 375 divided by 3. It's a non-calculator question, so I'm going to have to use the bus shelter method there. How many 3's go into 3? That's 1. How many 3's go into 7? That's going to be 2, and remainder 1. And how many 3's go into 15? That's 5, so that's 125. So a number cubed is 125, so if you cube root that, the cube root of 125 is equal to 5. So that means, again, that x is equal to 5. So x is equal to 5. Another approach is, remember, these are all prime numbers here. So if we take the 375 and write it as a product of primes, we can find out what these numbers are. So let's divide it by 5, because we know it's in the 5 times tables. So 375 divided by 5. How many 5's go into 3? 0, remainder 3. How many 5's go into 37? That's 7, which is 35, remainder 2. And how many 5's go into 25? That's 5. So 5 times 75 is 375. The 5's prime, so let's circle it. 75's not. It's in the 5 times table, so if we take our 75 and divide by 5, how many 5's go into 7? That's 1, remainder 2. And how many 5's go into 25? That's 5. So that's 5 times 15. The 5's prime, let's circle it. And 15 would be 3 times 5, and circle them both. So that means that 375 is 3 times 5 times 5 times 5. So we've got 3 times 5 cubed. So that means that x is equal to 5, because that's the number that's cubed here, 5. And that's it. So x is 5. So you could use either approach. You could either use the solve an equation approach there, or write it as a product of primes. Okay, let's look at our next question, question number 11. So question number 11, we've been told that m is equal to 2 cubed multiplied by 5. And we've been asked to work out what 10m is. So we just need to work out what 10m is. So we need to work out what this is worth. So let's work out what m is. So 2 cubed. So 2 cubed is 2 times 2 times 2. And 2 times 2 times 2 is equal to 8, because 2 times 2 is 4, times 2 is 8. So this is 8. And we've still got our times 5. And 8 times 5 is 40. So it means that m is equal to 40. So m is 40. But we've been asked to work out the value of 10m. So that's 10 times m. So that's 10 times 40. And 10 times 40 is 400. So 10m would be 400. And that's it. Okay, and then part B. Part B says to write 10m as a product of primes. So we know that 10m is 400, so that's 400. And we need to write it as a product of primes. So one approach is just take the 400 and do a prime factor tree and work out what that is. And I'll do that in a second. But I'm actually going to show you a quicker way to begin with. Because 10m, we know that m is equal to 2 cubed times 5. We were told that in the question. If we go up, 2 cubed times 5. So m is 2 cubed times 5. We want to write 10m as a product of primes. So we're timesing m, this, by 10. Now 10, if we take our 10, that's equal to 2 times 5. If you times something by 2 and then times it by 5, you're timesing the whole thing by 10. So if we take this, the 2 cubed times 5, and we times it by 2 and times it by 5, we'll get 10m. So that means that we just need to times this by another 2. So instead of being 2 cubed, it'll be 2 to the power 4. And instead of being 5, you times it by 5, so that'll be 5 squared. So that means that 10m would be 2 to the power 4 times 5 squared. So that would be, as a product of primes, 2 to the power 4 times 5 squared. And that's it. We've written 10m as a product of primes, because we knew what m was, and then we took our 10, we wrote it as a product of primes, which is 2 times 5. So we just took what m was and times it by 2 and times it by 5, and we got what 10m was. Alternatively, we could take the 400 and we could do a prime factor tree. So 2 times 200, circle the 2. 2 times 100, circle the 2. 2 times 50, circle the 2. 2 times 25, circle the 2. And 25 is 5 times 5. So you've got 2 times 2 times 2 times 2 times 5 times 5, or 2 to the power 4 times 5 squared. And that's it. We've worked out what 400 would be, or 10m is, as a product of primes. Okay, let's look at our next question. Now question number 12 is actually quite similar to our last question, question number 11, where we've been given what y is. It's 3 squared times 5 to the power 4. And we've been asked to write 50y as a product of its prime factors in index form. Now with this question, there's a couple of different approaches. One approach is to work out what 3 squared is, which is 9. And 5 to the power 4, which is 625. Multiply them together to get that number. So we're going to be in the thousands there. Then times that by 50 to work out what 50y is. Get that number. And then we're going to write it as a product of primes in index form. So doing a prime factor tree for that very large number. That's a 2-mark question. So I don't think the examiner intends you to actually work it out that way. But I just want to mention that you can use that approach if you really wanted to. So what I would do with this question is, we know what y is. It's 3 squared times 5 to the power 4. So it's 3 times 3. I'm just going to write it out in full here just so we can see it. 3 times 3 times, and then 5 to the power 4. 5 times 5 times 5 times 5. That's what y is. And 50, because we're working out what 50y is, 50, if we work that out as a product of primes, so 50 would be 2 times 25, 2's prime, 25's not, so that's 5 times 5, circle them both. 50 is equal to 2 times 5 times 5, or 2 times 5 squared. So if you times a number by 2, and then times it by 5, and then times it by 5, that's going to be the same as timesing a number by 50. So if we take this number here, which is y, this 3 times 3 times 5 times 5 times 5 times 5, or 3 squared times 5 to the power 4, and we times this by a 2, a 5, and a 5, then you're going to be timesing the whole thing by 50. And the great thing is it will be already written as a product of primes. So let's do that. So let's take this, or this, whichever one you prefer, and times it by a 2, a 5, and a 5. So I'm going to do it with this one, or 3 squared times 5 to the power 4. If you times it by 2, it's just going to put a 2 in front of it. And then we're not timesing it by any 3, so it's still going to be times 3 squared. And then we're timesing it by 5 and by 5 again. So instead of it being 5 to the power 4, it'll be 5 to the power of 6. So that means that 50y would be equal to 2 times 3 squared times 5 to the power of 6. We've taken this and we've times it by a 2, a 5, and a 5. And we've got that. So it's 2 times 3 squared times 5 to the power of 6. And that's it. Or you could have taken this version, which is our 3 times 3 times 5 times 5 times 5 times 5. We're timesing it by a 2, a 5, and a 5. So you could just write in the end times 2 times 5 times 5. And then write that in index form, which would be 2 times 3 squared times 5 to the power of 6. So 5 to the power of 6. And I actually find that one actually a little bit easier, just actually seeing them all written out like that. And then you can get the product of primes that way as well. Okay, let's look at our next question, question number 13. So question number 13. So now what we're going to do is we're going to look at how we can use the product of primes to find the highest common factor and the lowest common multiples of pairs of numbers, or even maybe 3 numbers. But I think we're going to be starting off by looking at pairs of numbers here. So part A says write 48 as a product of its prime factors. So let's take 48 and let's do a prime factor tree for it. Again, you could use the upside down bus shelter method if that's what you like. Feel free to, as long as you're getting the right answers, that's all that matters. So 48, 2 times 24, circle the 2. 24, 2 times 12, circle the 2. 12, 2 times 6, circle the 2. 6, that's 2 times 3, circle the 2 and the 3. So that's 2 times 2 times 2 times 2 times 3. So that's 2 to the power of 4 times 3. Now we weren't actually asked to write an index form, so you could write it out as 2 times 2 times 2 times and so on, times 3. And you could write it out as 2 to the power of 4 times 3. So that's what 48 is as a product of its primes. Then part B, we've been asked to find the highest common factor of 48 and 56. So what we actually want to do is write both of these numbers as the product of primes. So we know that 48 is equal to 2 times 2 times 2 times 2 times 3. And it'd be handy if we knew what 56 was. So 56, you can then write that as a product of primes, and then we can use that to find the highest common factor. Okay, so let's write 56 as a product of primes. So 2 times 28, circle the 2. 28 would be 2 times 14, circle the 2. And 14 would be 2 times 7, circle them both. So that means that 56 is 2 times 2 times 2 times 7. And that's it. So we've got 48 is equal to 2 times 2 times 2 times 2 times 3. And 56 would be equal to 2 times 2 times 2 times 7. Now, if we want to find the highest common factor and the lowest common multiple, we can actually use the product of primes to help us. Now, some people look at these, and if they want to find the highest common factor, they look at these lists of the prime numbers. So look at these lists, and they underline the ones that they share. So that's got a 2 and a 2. That one's got a 2 and a 2. That one's got a 2 and a 2. And then if we look at the rest of them, there's nothing else that's shared. And then to find the highest common factor, you can times the ones that they share. So you could do 2 times 2 is equal to 4, times the number 2 is equal to 8. And some people do it that way. What I tend to do is whenever I'm working out the highest common factor and lowest common multiple, I do 2 circles. I do a circle here for 48, a circle here for 56, and it just helps me visualize which ones they share. So this is really the same thing, but it's just a more visual way for me to see it. So instead of underlining the 2's that they share, what I'm going to do is I'm going to put what they share in the middle. So if we have a look here, let's see what they share. So 48's got 2's, so it's got 4 2's, and 56 has got 3 2's. So they both have 3 2's, so 1, 2, 3. So as you can see here in the 48 circle, there's 3 2's, and the 56 circle, there's 3 2's. But 48 actually had 4 2's altogether, so there's another 2 there, so I'm going to put another 2 there. So if we have a look at the 2's here, we've got 3 2's in the middle, so that means that in the 48 circle, it's got 4 2's altogether, and the 56 circle, they've got 3 2's. So we've put the ones they share in the middle and the extra 2 on the 48 side. Okay, now let's deal with the 3's. 48 is only one of a 3, so let's put a 3 over on that side, and the 7, that's going to go on the 56 side. So if we have a look at our two circles, the 48 circle, we've got 2 times 2 times 2 times 2 times 3, fantastic. And the 56 circle, we've got 2 times 2 times 2 times 7, 2 times 2 times 2 times 7, that's fantastic. So it's just a more visual way of seeing which prime numbers they share and which prime numbers are just on either the 48 side or the 56 side. Okay, so now we've got this diagram. If we want to find out what the highest common factor is, we multiply the prime numbers in the middle, because the highest common factor is the biggest number that both of these numbers are divisible by. So if we do 2 times 2 times 2, that's equal to 8, so 2 times 2 times 2 is equal to 8. So it means that both of these numbers are divisible by 8. And that's actually the biggest number that you can actually divide both of these numbers by, so it's the highest common factor. So if you multiply the numbers in the middle, that's going to give you the highest common factor, so that's equal to 8. If we wanted to find the lowest common multiple of 48 and 56, we would times all these numbers together, so we would do 2 times 3 times 2 times 2 times 2 times 7. But the question just asks us for the highest common factor, so we just times the ones in the middle. So that's it. Okay, so let's have a look at our next question, question number 14. So question number 14 is very similar to question number 13 because these questions are quite common, where part A you're asked to write a particular number as a product of its primes, and then part B you're asked either to find the highest common factor or the lowest common multiple, the LCM in this case, of the number you've written as a product of primes and then another number. So let's have a look at question number 14a. So it says to write 60 as a product of its prime factors. So let's do our prime factor tree. So in terms of 60, I'm thinking of two numbers that multiply together to be 60. So I'm going to go for 2 and 30. 2's prime, so let's circle it. 30, well, let's go for 3 and 10. 3's prime, so let's circle it. And then finally 10, 2 times 5. And they're both prime, so let's circle them both. So we've got 60 is equal to 2 multiplied by 2 multiplied by 3 multiplied by 5. And I've just put them in order. I've done 2 times 2 times 3 times 5. And if we wanted to, we could write it in index form as 2 squared multiplied by 3 multiplied by 5. And let's just check that. 2 squared is 4, times 3 is 12, times 5 is 60. So we know we're right. Okay, and then part B. Part B, we've been asked to find the lowest common multiple of 60 and 70. So you want to find the first number in both of their times tables. So you could, if you wanted to, write down the multiples of 60, the multiples of 75, and then find the lowest common multiple, the first number in both of those lists. Alternatively, what we're going to do is we're going to write 75 as a product of primes, so 75. And a product of primes, well, it's in the 5 times tables. It ends in a 5, so let's go for 5 times 15. 5's prime, so let's circle it. 15's not, so let's go for two numbers at times together to be 15. I'm going to go for 3 and 5, and let's circle them both because they're both prime. So it means that 75 is equal to 3 times 5 times 5, and 60 we had that was equal to 2 times 2 times 3 times 5. So we've got both numbers written as product of primes. Now let's do our two circles. So we've got our little diagram here with our two circles. We have got one circle for 75 and one circle for 60. And what we're going to do is we're going to put any prime numbers that they share, any prime factors that they share in the middle, and then any that they just have, put them on their side. Okay, so now let's put these prime numbers in the diagram. So let's start off with 2's. 60 has got two 2's, but 75 doesn't have any. So that means the two 2's are going to go in the 60 side. Then if we have a look at 3's, they've both got 1 3. So that means we can put 1 3 in the middle. That's fantastic. So we've done 2 and 3. Now let's have a look at 5. We know that here that 60 has got 1 5 and 75 has got 2 5's. So that means they've both got 1 5. So let's put 1 5 in the middle. And 75's got an extra 5. So let's put 1 5 over there. So we've put the numbers in the diagram, and let's just check it. In the 75 circle, we've got 5, 3 and 5. Fantastic. And in the 60 circle, we have got 2, 2, 3 and 5. Perfect. So put the numbers in the diagram. Now what we want to do is we want to find the lowest common multiple. So if we want to find the lowest common multiple, we're going to multiply all these numbers together. If we wanted to find the highest common factor, we would just do 3 times 5, which is 15. But we don't want to find the highest common factor in this question. We want to find the lowest common multiple. So the lowest common multiple will be equal to 5 times 3 times 5 times 2 times 2. So we're just timesing all those numbers together. And then if we do this, well, 5 times 3 is equal to 15. Times by 5 is equal to 75. Times by 2 is equal to 150. Times 2 is equal to 300. And that's it. Now you could multiply these numbers in a different order. You could do 2 times 5 is 10. Times 2 is 20. Times 3 is 60. Times 5 is equal to 300 and so on. But you're going to get 300. So that means the lowest common multiple of these two numbers is 300. And we use the product of primes to help us. Okay, let's look at our next question, question number 15. Okay, so question number 15, part A, we've been asked to write 132 as a product of its prime factors. So let's do a prime factor tree. Okay, so I'm going to start off by looking at it and see, well, it's even. So that's going to be 2 times, and half of 132 would be 66. 2's prime, so let's circle it. 66 isn't, so we're going to go for 2 and 33. 2's prime, so let's circle it. 33, let's go for 3 and 11. And they're both prime, so let's circle them both. So that means that 132 is equal to 2 multiplied by 2 multiplied by 3 multiplied by 11. And we can check that. 3 times 11 is 33, times 2 is 66, times 2 is 132. And we could write it in index form if we wanted to. We haven't been asked to in this question, but we're going to do it anyway. 2 squared multiplied by 3 multiplied by 11. And that's it. And then part B, we've been asked to find the highest common factor of 88 and 132. Now we know that 132 is equal to 2 times 3 times 11. Now I don't actually tend to write that one in index form. I tend to write it out in full just so that whenever I'm putting the numbers in the diagram, I can see them out in one big list. And then 88, let's write that as a product of primes. So I'm going to go for 4 times 22. Neither of those are prime, so 4 is equal to 2 times 2, and they're both prime, so let's circle them both. And 22 is equal to 2 times 11, and let's circle them both. So that means that 88 is equal to 2 times 2 times 2 times 11. So we've got both of these numbers as a product of their primes. Now let's do our diagram. So we've got our circles. Okay, so we've got our two circles, one for 132 and one for 88. Okay, so let's start off by looking at the 2's. 132 has got 2 2's and 88 has got 3 2's. So they both share 2 2's, so let's put 2 2's in the middle. And 88's got an extra 2, so we need to have one extra 2 on that side. So let's just check that. 132 has got 2 2's in its circle and 88 has got 3 2's in its circle. And then 132 has got a 3, so a 3 is going to need to go on that side. And then they both share 11, so let's put 11 in the middle. So we have got here our numbers in the diagram. Now let's multiply. We want to find the highest common factor. So to find the highest common factor, we multiply the numbers in the middle. So we're going to do 2 times 11. So 2 times 2 times 11. And 2 times 2 is 4, times 11 would be 44. So the highest common factor of 88 and 132 would be 44. And that's it. Okay, let's look at our next question. So question number 16, we've been asked to find the lowest common multiple, or the LCM, of 28 and 63. So I'm going to write both numbers as a product of their prime factors, and then I'm going to do the circles, and then I'm going to find the lowest common multiple by multiplying all the numbers in the diagram. So let's start off with 28. So 28. Two numbers that multiply together to be 28. I'm going to go for 2 and 14. 2's prime, so let's circle it. 14 was 2 times 7, and let's circle them both. So that means that 28 is equal to 2 times 7. Now let's look at 63. And two numbers that multiply together to be 63. I'm going to go for 7 times 9 is 63. 7's prime, so let's circle it. 9's not, so let's go for 3 times 3, and then circle them both. So that means that 63 is equal to 3 times 7. So that's fantastic. We've got both numbers written as a product of the prime factors. Now we want to find the lowest common multiple, so let's do our diagram, our circle and our other circle. One for 28 and one for 63. Okay, so for 28 and 63, let's look at the numbers. So 2's. 28 is the only one that's got 2, so let's put the 2 2's on the 28 side. 63 has got 3, so let's put the 2 3's on the 63 side. And they both share 7, so let's just put 1 7 in the middle. And let's just check that. 28 has got in its circle 2 times 7. And 63 has got 3 times 7. So that's perfect. We've got all the numbers in the right places in the diagram. Now we want to find the lowest common multiple. So if it was the highest common factor, we would just times together the numbers in the middle, which would just be 7. But in this case, we want to find the lowest common multiple, so we're going to multiply all the numbers on the diagram. So we're going to do 2 times 7 times 3 times 3. So 2 times 7 times 3 times 3. And let's work that out. 2 times 2 is equal to 4. Times 7 is equal to 28. Now we need to multiply that by 3. I'm actually just going to use my column method of multiplication here. So 28 multiplied by 3. 3 times 8 is 24. Put a 4 down and carry our 2. 3 times 2 is equal to 6, plus 2 is equal to 8. So that's equal to 84. If we do 28 times 3, that's 84. Now we need to times by 3 again, so 84 multiplied by 3. So 3 times 4 is equal to 12. Put a 2 down and carry a 1. 3 times 8 is equal to 24, plus 1 is 25. So that's 252. So that means the lowest common multiple of 28 and 63 is 252. And that's it. Okay, let's look at our next question, question number 17. Okay, so question number 17, we've been asked to find the lowest common multiple, or the LCM, of 36 and 54. So we want to find the lowest common multiple of both 36 and 54. So again, I'm going to write both of these numbers as a product of their prime factors. Then we're going to do the diagram, and then we're going to multiply all the numbers in the diagram together because we want to find the lowest common multiple. So let's start off with 36. So 36, 2 times 18, circle the 2, it's prime. 18, well, I'm going to go for 2 times 9, circle the 2. And then 9, I'm going to go for 3 times 3. So that means that 36 is equal to 2 times 2 times 3 times 3. And then 54, so if we've got 54 as a product of its primes, well, 2 times 27 is 54, circle the 2. 27, I'm going to go for 3 times 9, 3 is prime, so let's circle that. And then finally 9, I'm going to go for 3 times 3. So we now know that 54 is equal to 2 times 3 times 3 times 3. So that's fantastic. We've got both numbers written as a product of their prime factors. Now let's do our circles. So a circle here for 36 and a circle for 54. It's 36 and 54. And let's put the numbers in the diagram. So let's start off with 2's. So 36 has got 2 2's and 54 has got 1 2. So that means we can put 1 2 in the middle, and 36 has got an extra 2, so let's put the 2 over on that side. So if we have a look here, we've got 2 2's in the 36 circle and 1 2 in the 54 circle. So we've done the 2's. Now let's have a look at the 3's. 36 has got 2 3's and 54 has got 3 3's. So they both share 2 3's, so we can put 2 3's in the middle, and the 54 has got an extra 3, so let's put a 3 on the 54 side. So let's just check that. In the 36 circle, we've got 2, 2, 3, and 3. And in the 54 circle, we've got 2, 3, 3, and 3. And that's right. So we want to now find the lowest common multiple, so the lowest common multiple. So let's multiply all these numbers together. So let's do 2 times 2 times 3 times 3 times 3. And let's see what we get. 2 times 2 is equal to 4, times 3 is equal to 12, times 3 is equal to 36, and then we've got 36 times 3, so 36 multiplied by 3. 3 times 6 is 18, put an 8 down and carry a 1, and 3 times 3 is 9 plus 1 is 10, so that's equal to 108. So the lowest common multiple of 36 and 54 is 108, and that's it. Okay, let's look at our next question. Okay, so question number 18, it's a calculator question, so we can use our calculator to help us in this question. And here we've got the 480 is equal to 2 to the power 5 multiplied by 3 multiplied by 5. And we've been asked to find the highest common factor, or the HCF, of 480 and 168. Now it's great, we've got 480 already written as a product of its prime factors for us, so it'd be really great if we knew what 168 was as a product of its prime factors. So let's just use our calculator to do that. So what we're going to do is we're just going to use our calculator to write 168 as a product of its prime factors. And remember, we've looked at that earlier on in the video, so we've looked at how to do that. So we're just going to type in 168 and then get it as a product of its prime factors, and that's equal to 168 will be equal to 2 cubed multiplied by 3 multiplied by 7. So that's fantastic. We've now got both numbers written as a product of their prime factors, and we've used our calculator to help us with this one. Okay, now let's do our two circles. So here we've got our two circles, one for 480 and one for 168. So now what we're going to do is we're going to put these numbers in the diagram. And if you wanted to, you could write them out in full. You could do 2 times 2 times 2 times 2 times 2. I think I said the right number of 2's there. Times 3 times 5. And you could do 2 times 2 times 2 times 3 times 7 for this one if you wanted to. I'm just going to look at it. So let's start off with the 2's. 168 has got 3 2's, and 480 has got an extra 2 2's because it has 5 2's altogether. So we need to put an extra 2 2's on that side. And let's just check that. The 480 has got 5 2's and 168 has got 3 2's. Okay, now let's look at the 3's. They've both got 1 3, so let's put just 1 3 in the middle. 480's got a 5, so let's put a 5 on that side, and 168 has got a 7, so let's put a 7 on that side. So that's fantastic. We've now put all the numbers in the diagram. We want to find the highest common factor, so we're going to times the numbers in the middle. So the highest common factor would be equal to 2 times 2 times 2 times 3. And if we work that out, if we times these numbers together in the middle, we get 2 times 2 is equal to 4, times 2 is equal to 8, times 3 is equal to 24. So it means the highest common factor of 480 and 168 is 24. And that's it. Okay, let's look at our next question, question number 19. Okay, so question number 19, we've been given these two numbers, C and D, and they've already been written as a product of their primes, which is fantastic. The question actually doesn't ask us to work out what C and D are, so we don't actually need to know what the two numbers are. We just need to, part A, find the highest common factor, and part B, find the lowest common multiple. So what I'm going to do is I'm going to do our diagram, our circle for C and our circle for D. Okay, let's start off with the 2's. C has got 5 2's and D has got 1 2. So we're going to put 1 2 in the middle because D's got 1 2 and C's got 5 2's, so they share 1 2. But C's got an extra 4 2's, so let's put 4 more 2's on that side. Okay, now let's look at the 3's. C has got 2 3's and D has got 2 3's, so we can put both of those in the middle, 3 and 3. D has got a 5, so let's put a 5 on that side because D has got a 5 and C doesn't. And then finally the 7's. C has got 4 7's and D has got 2 7's, so we can put 2 7's in the middle, so 2 7's in the middle. But C's got an extra 2 7's, so we need to put an extra 2 7's on its side. And let's just check that. If we look at the C circle, it has got 5 2's, 1 2 3 4 5, 2 3's, 1 2, and 4 7's, 1 2 3 4. Okay, and then if we look at the D circle, we've got a 2, yep. We've got 2 3's, yep, a 5 and 2 7's. So that's perfect. So part A says find the highest common factor. So the highest common factor. So to find the highest common factor, we're going to times the numbers in the middle. So we're going to do 2 times 3 times 3 times 7 times 7. And this is great. It's a calculator question, so we just need to times this on the calculator and see what we get. So 2 times 3 times 3 times 7 times 7 is equal to 882. So the highest common factor of these numbers is 882. Okay, and then part B says find the lowest common multiple of these numbers, so we need to multiply all the numbers in the diagram. So we need to do 7 times 2 times 2 times 2 times 2 times 7, that's those numbers. And then we've got times 2 times 3 times 3 times 7 times 7, and then we've got times 5. And I'm just going to check this because there's a lot of numbers there. 7 times 2 times 2 times 2 times 2 times 7 times 2 times 3 times 3 times 7 times 7 times 5. Yep. And now I'm going to type it into the calculator, and I'm going to be really careful when I'm typing this in. 7 times 2 times 2 times 2 times 2 times 7 times 2 times 3 times 3 times 7 times 7 times 5. And when we do that, we get an answer of 3,457,440. And that's it. And now you can see why it's a calculator question. Okay, let's look at our next question. Okay, so question number 20, it's a non-calculator question, so I'm putting the calculator down. And part A says we've been given that 45 is 3 squared times 5. 3 squared is 9 times 5 is 45. Fantastic. We've been asked to write these numbers as a product of their prime factors in index form. So you could, if you wanted to, for each of these, do their own prime factor tree if you wanted to. But what I'm going to do is I'm just going to look at the fact that, well, so if we know that 45 is 3 squared times 5, or 3 times 3 times 5, that's what 3 squared times 5 is, 3 times 3 times 5. If we wanted to find out what 90 is as a product of primes, well, we would just take our 45 and we would times it by 2. If you double 45, you get 90. So if we times these numbers by 2, you'll get 90. So that means that if we had 45, which is 3 times 3 times 5, and we double it, which is timesing by 2, that would be 90. And we can check it. 2 times 5 is 10, times 3 is 30, times 3 is 90. So we've been asked to write these as a product of primes in index form, so that'll be 2 times 3 squared times 5. And that's what 90 is as a product of primes in index form. Okay, next, 135. So again, 45 is 3 times 3 times 5. That's 45. And if we think of our 45 times tables, we've got 45, and then add another 45 is 90, add another 45 is 135. So 135 is 3 times 45. So if you just take this and times it by 3, you get 135. And in index form, that would be 3 cubed times 5. So 3 cubed times 5. And that's what 135 is. Okay, and then our next one, 450. Well, again, we know that 45 is 3 times 3 times 5. That's 45. But we want 450, which is 10 times larger. So we want to times this by 10. But 10's not prime. So what we're going to do is we're going to think, well, 10 is 2 times 5. If you times a number by 2 and then times it by 5, it's the same as timesing it by 10. So instead of just writing here times 10, I'm actually going to write times 2 times 5. I've considered what 10 is as a product of its primes, and then I've just times 45 by the 2 and the 5. Now we want to write that in index form, so it's going to be 2 times 3 squared times 5 squared. And that's it. And we can check that. 5 squared is equal to 25, times 2 is equal to 50, times 9 would be equal to 450. Okay, let's look at our next one. Part B says find the lowest common multiple, or the LCM, of 36 and 45. So 45, if we go back up, that's equal to 3 squared times 5. So 45 is equal to 3 times 3 times 5. 3 squared, which is 9 times 5. 36, let's write it as a product of primes, so 36, 2 times 18 is 36, so let's circle the 2, it's prime. 18, 2 times 9, circle the 2, and 9, 3 times 3. So we now know that 36 is equal to 2 times 2 times 3 times 3. So that's fantastic. We've got both of the numbers as a product of its prime factors. Well, they're prime factors. Now let's do our circle. So circle for 36 and a circle for 45. So 36 and 45. Okay, so let's start off with the 2's. 36 has got 2 2's. So let's put 2 2's on its side. That's straightforward. Okay, 45 now has got 2 3's and 36 has got 2 3's. So they both have 2 3's. You can put 2 3's in the middle. And 45 has got a 5. So that's fantastic. Now we want to find the lowest common multiple, so we're going to multiply all the numbers together in the diagram. So we're going to do the lowest common multiple will be equal to 2 times 2 times 3 times 3 times 5. Now it's a non-calculator question, so I'm going to do the multiplication in an order that I want to. I'm going to do 5 times 2 is 10, times 2 is 20, times 3 is 60, times 3 is 180. So the lowest common multiple of 36 and 45 is 180. And then part B says find the highest common factor of 36 and 45. So we're going to times together the numbers in the middle. The highest common factor would be equal to 3 times 3. And 3 times 3 is equal to 9. So that's it. We've found the lowest common multiple and the highest common factor. Okay, let's look at our next question. So question number 21a says express 108 as a product of its prime factors and to give our answer in index form. Okay, so we're going to be starting with 108 and we want to write that as a product of primes. So I'm going to go for 2 and 54. 2 is prime, so let's circle that, but 54 is not. 54 I'm going to go for 2 times 27, and again the 2 is prime, 27 is not. So 27 I'm going to go for 3 times 9 because 3 times 9 is 27. The 3 is prime, so let's circle it, and in terms of the 9 that's going to be 3 times 3. So that's it, we've got 2 times 3 times 3 times 3. So it means that 108 is equal to 2 times 2 times 3 times 3 times 3. Now we've been asked to give our answer in index form, so that's going to be that's equal to 2 times 2 is 2 squared, and then 3 times 3 times 3, there's 3 of them, so it's going to be 3 cubed. So the answer is 2 squared multiplied by 3 cubed. Okay, and then part B. Part B, we've been asked to find the highest common factor of 108 and 72. So 108, we know that's equal to 2 squared multiplied by 3 cubed. Now let's write 72 as a product of primes. So 72 would be equal to, well, it's 2 times 36. The 2 is prime, so let's circle it. 36 isn't. 36, that's going to be 2 times 18, and circle the 2. And then in terms of 18, I'm going to go for 2 times 9, circle the 2. And then in terms of the 9, I'm going to do 3 times 3, and circle them both. So that means that 72 would be equal to 2 times 2 times 2 times 3, or 2 cubed times 3 squared. 2 cubed times 3 squared. So we've written both numbers as a product of the prime factors. Now let's do our diagram. So we've got a circle for 108. We've got another circle for 72. And we want to put our prime numbers in the diagram. So let's start off with the 2's. 108 has got 2 2's and 73 has got 3 2's. So that means that 72's got one more 2 than the 108. So that means that 2 2's are going to go in the middle and an extra 2 on the 72 side. And let's just check that. In the 108 circle, there's 2 2's. And in the 72 circle, there's 3 2's. Okay, now let's look at the 3's. 72 has got 2 3's and 108 has got 3 3's. That means that 108 has got an extra 3. So we're going to put 2 3's in the middle, a 3 and a 3, and an extra 3 on the 108 side. So we've put all the numbers in the diagram. Now we want to find the highest common factor, so we're going to multiply the numbers in the middle. So we're going to find the highest common factor. We're going to do 2 times 2 times 3 times 3. So we've got 2 times 2 times 3 times 3. 2 times 2 is 4, times 3 is 12, times 3 is 36. So that means the highest common factor of 108 and 72 is 36. And that's it. Okay, let's look at our next question. Okay, so question number 22, we've been asked to find the lowest common multiple, or the LCM, of 140 and 200. So if we want to find the lowest common multiple of 140 and 200, what we want to do is we want to write both of their numbers as a product of the prime factors. So let's do that, 140 and 200. So let's start off with 140. That's going to be 10 times 14. Neither of them are prime, so let's start off with the 10. That's going to be 2 times 5. They're both prime, so let's circle them both. And 14, that's 2 times 7. And they're both prime, so let's circle them both. So that means that 140 would be equal to 2 times 2 times 5 times 7. So 2 times 2 times 5 times 7. And then 200, well, let's do 10 times 20. Then let's look at the 10, that's going to be 2 times 5, and let's circle them both. And then the 20, well, I'm going to go for 2 times 10, circle the 2, and then the 10 we'll do 2 times 5. So we've now worked out what 200 is. It's going to be 2 times 2 times 2 times 5 times 5. So 2 times 2 times 2 times 5 times 5. So that's fantastic. We've written both numbers as a product of the prime factors. Now let's do our diagram. So we're going to do a circle for 140 and a circle for 200. Okay, so let's look at the 2's. 140's got 2 2's and 200 has got 3 2's. So that means that 200 has got one more 2. So we're going to put 2 2's in the middle and an extra 2 on the 200 side. Then let's look at the 5's. 140's got 1 5 and 200 has got 2 5's. So that means we'll put 1 5 in the middle and an extra 5 on the 200 side. And then finally 140's got a 7, so that means that's going to go there. And we want to find the lowest common multiple, so we're going to need to multiply together these numbers. So the lowest common multiple of 140 and 200 would be found by doing 7 times 2 times 2 times 5 times 2 times 5. Okay, now we need to multiply these together. Okay, so it's a non-calculator question, so I'm going to choose some nice multiplications to do to begin with. So 2 times 5 is 10, times 5 is 50, times 2 is 100, times 2 is 200, times 7 will be 1,400. So the answer will be 1,400. So the lowest common multiple of 140 and 200 is 1,400, and that's it. Okay, let's look at our next question, question number 23. So question number 23a says, work out 6 times 12 as a product of prime factors, and to give our answer in index form. So one way we could do this question is to just work out what 6 times 12 is, which is 72, and then just write 72 as a product of primes. That'd be totally fine. Another way to do it is to write 6 as 2 times 3, because 6 is 2 times 3 as a product of primes. 12 would be 2 times 2 times 3, because if you do a prime factor tree for 12, you get 2 times 2 times 3, 4 times 3. And then finally, we just need to times them together. So that'll be 2 times 2 times 2 times 3 times 3, which is 2 cubed times 3 squared. And let's just check that. 2 cubed is 8, 3 squared is 9, 8 times 9 is 72. Or as I said, you could just do 72 because you know 6 times 12 is 72, and then do your prime factor tree for 72. And when you do that, and you do your prime factor tree for 72, and just like how you've done all the other prime factor trees, you're going to get that's equal to 2 times 2 times 2 times 3 times 3, or 2 cubed times 3 squared, and that's it. Okay, let's look at our next part, part B. Part B says find the highest common factor of y and 5y. Well, we're trying to find the biggest thing we can divide both of these things by. Well, that would just be y. So the answer would be y, because you can divide y by y and 5y by y, and that's it. Okay, let's look at our next question, question number 24. So question number 24 says, write 1008 as a product of prime factors and to express our answer in index form. Now, this is a calculator question, so we can do this on our calculator, and I'm just going to write it down now because we've looked at over questions we've done on our calculator, so I don't need to actually show you how to do that, so hopefully you'll be able to do that. So if we just get our calculator and type in 1008, press equals, and then get it as a product of primes, 2 to the power of 4 multiplied by 3 to the power of 2 multiplied by 7. And that's it. That's 1008 as a product of primes, and our answer is in index form. Okay, and then part B. Part B says, so we know that 1008 is equal to 2 to the power of 4 multiplied by 3 squared multiplied by 7. And we've been asked to find the lowest whole number which 1008 would need to be multiplied by to get a square number. So we want to find out what number you'd have to multiply this by to get a square number, the lowest number you can multiply by to get a square number. Okay, now what we know is that a square number is what you get whenever you multiply something by itself. So if we have something, and I'm just going to do a circle here to represent this number, and we're going to multiply that by the same number, then the answer then will be a square number if you multiply the same thing together. So what we're going to do is we're going to use this the product of primes to help us. We're going to share these prime numbers out in between these two numbers, and then we're going to figure out what other number or other numbers we would need to then have a square number as our answer. So here we've got 2 to the power of 4. Well, if we had 2 to the power of 4, we could have 2 2's in this circle and 2 2's in this circle. And here we've got 3 squared. Well, we could put a 3 there and a 3 there. And then finally we've got the 7. Well, we could put the 7 there, but we don't have a 7 here. So what I'm going to do is I'm just going to get a 7 and put it in there. And that means then if we multiply this number by this number, remember this number is what we get when we multiply these numbers together, and this number is what we get when we multiply these together. If you multiply these two things together, you're going to get a square number. So that means that if we take our numbers here, the numbers in red, which is 1008, and multiply by 7, the answer will be a square number. So let's have a look and see if that's the case. So if we take 1008 and we multiply that by 7, so we do 1008 and multiply that by 7, that's equal to 7056. So that means that if you multiply this number by 7, you would get 7056. Now we need to check if this is a square number. So if we do the square root of 7056, that's equal to the square root of 7056, that's equal to 84. So yeah, so this is 84 times 84. So we wanted to find what you'd need to multiply this by to get a square number. So if we multiplied it by 7, you would get 7056, which is a square number. And how I done that was I just considered, well, if it's a square number, we're going to have something multiplied by itself. I shared out the prime numbers as equally as I could, and then I just figured out which ones we'd need. Now there is actually a bit of a shortcut. If whenever you write a number as a product of primes, and all the powers of the prime numbers are even, then it'd be a square number. So 2 to the power 4, you get an even power there, fantastic. 3 squared, that's an even power, fantastic. Here we've just got 7, which is 7 to the power of 1. We would need to multiply that by another 7 to get an even power, so it'd be 7 squared. So as you can see here, we just need to multiply the whole thing by 7. So the answer would be 7, and that's it. Okay, let's look at our next question, question number 25. So question number 25 says, find the lowest common multiple of 19 and 34. Now, if I actually look at this one, I can actually see straight away, I'm just actually going to get the answer by doing 19 times 34, because 19 is a prime number, and it's not a factor of 34, so that means that if we were to consider the diagram, so if we had the diagram here with 19, a circle for 19 and a circle for 34, because 19 is a prime number and 34 doesn't have 19 as a factor, the 19 would just go there, and 34 as a product of primes would be 2 times 17, and they're both prime, so 2 and a 17. And then if we wanted to find the lowest common multiple, we would just do 19 times 2 times 17. Now 2 times 17 is 34, so actually we're just doing 19 times 34 for this particular question, and that will give us the lowest common multiple. So let's do that. 34 multiplied by 19. So 9 times 4 is 36. Put a 6 down and carry a 3. 9 times 3 is 27 plus 3 is 30. Now we're going to multiply by 10, so put a 0 down. 1 times 4 is 4, and 1 times 3 is 3. And then let's just add them up. 6 plus 0 is 6. 0 plus 4 is 4, and 3 plus 3 is equal to 6. So the answer would be 646. And that's it. That's the lowest common multiple of 19 and 34. Okay, let's look at our next question, question number 26. Okay, question number 26 is a bit like one of the ones we looked at previously whenever we looked at what we needed to multiply a number by to get a square number. Here we've got 16,200 is 2 to the power of 3 multiplied by 3 to the power of 4 multiplied by 5. And we've been asked to write down the lowest whole number which we need to multiply this by to get a cube number. So again, we could consider it in two different ways. One approach, and I mentioned this whenever we looked at how to get a square number, if you want a square number, you want all the powers to be even. If you want a cube number, you want all the powers to be multiples of 3. So here we've got 2 to the power of 3, that's fantastic, 2 to the power of 3 is fine, multiply by, and then here we've got 3 to the power of 4, but 4 is not a multiple of 3. But 6 is. So if you multiply by 3 and by 3 again, you would get 3 to the power of 6, and that would be fantastic. And then, so that's multiplying by 3 and by 3 again, or 3 squared. If you do 3 to the power of 4 times 3 squared, you get 3 to the power of 6. And then finally, we had 5 squared, but it has to be, to get a cube number, all the powers have to be multiples of 3. So what would we multiply this by? Well, we just multiply by 5, because if you have 5 squared and you times it by 5, you get 5 cubed. And now, this number here, all the powers are multiples of 3. So this would be a cube number. And we can just check it out. If we do 2 to the power of 3, multiplied by 3 to the power of 6, multiplied by 5 to the power of 3, that's equal to 729,000. And then if we cube root that, so if we cube root that, that's equal to 90. So that is a cube number. So in terms of the lowest possible number we'd need to multiply 16,200 by to get a cube number, you would then just do, because we times the 3 to the power of 4 by 3 squared to get 3 to the power of 6, that's going to be 9, because 3 squared is 9, and then times 5. And then 9 times 5 is equal to 45. So if we took 16,200 and we multiplied it by 45, you'd get a cube number, and that'd be the lowest possible whole number you could multiply that by to get a cube number. Now, that's one approach. Another approach would be actually to consider our little diagram and to think, well, now the answer I'm just going to write it in there again is 45. Another approach would be to consider, well, a cube number is what we get when we multiply a number by itself and by itself again. So if we share these prime numbers into this diagram as equally as possible, then we just need to figure out what else we'd need. So we've got 2 to the power 3, so we can put a 2 there, a 2 there, and a 2 there. Fantastic. 3 to the power 4, well, let's put a 3 there, a 3 there, and a 3 there. Unfortunately, we've got one more 3, so let's put it there. We have to put it in a circle, so it's going to go there. So we're going to need 2 more 3s, so I'm just going to put those in, a 3 and a 3. And then finally, we've got 2 5s, so we can put a 5 there and a 5 there, but we're going to need another 5, so let's put another 5 in that one. So if we wanted to get a cube number, we'd have to do that, times that, times that. And remember, this number is just what we get when we do 2 times 5, which is 10, times 3, which is 30, times 3 is 90. So if we do 90 times 90 times 90, we'd get that cube number. Now, we needed to figure out what we would have to multiply the 16,200 by. So that's all the numbers in red, because remember, 2 to the power 3 is our 3 2s, 3 to the power 4 is our 4 3s, and 5 squared is our 2 5s. We've added in the numbers in blue, so we're going to have to do 3 times 3 times 5, so 3 times 3 times 5. And 3 times 3 is 9, times 5 is equal to 45. So that means that if we multiply this by 45, we get a cube number, and that's it. Okay, let's look at our next question, question number 27. So question number 27, we've got this number, 4,116, and that's equal to 2 squared times 3 times 7 cubed. And we need to write down the lowest integer that we need to multiply this number by to get a square number. So we want a square number. Now, there's a few different ways we can do this. One approach, again, is to know, well, if we want to get a square number, when you write it as a product of primes, all the powers are even. So 2 squared, yes. 3, that's 3 to the power of 1, so no, we would need to multiply that by another 3. If we multiply that by 3, we'd get 2 squared times 3 squared. And then we had 7 to the power of 3, that's an odd power, we need to multiply that by another 7. So it'd be times 7 to the power of 4. So if you multiply by another 3, you'd get 3 squared, and if you multiply by 7, you'd get 7 to the power of 4. So that means that if we have our number 4,116 and you times it by 3 and times it by 7, you should get a square number. And let's just check that. If you have 4,116 and you multiply it by 3 and multiply it by 7, you get that's equal to 86,436. And is that a square number? Let's square root it, 294. So yeah, now if you times something by 3 and then times it by 7, that's the same as timesing. 7 times 3 is equal to 21. So if we multiply this number by 21, you get that's equal to a square number. And that's it. So that's one approach. Another approach is to consider, remember, get our diagram. And we do a circle and then another circle, because for it to be a square number, you've got 2 numbers that you're going to times together and they're the same number. And we're going to share out what we've got. So 2 squared, that's a 2 and a 2. Fantastic. 3, unfortunately, we can only put that in one circle, so we're going to need to have another 3, so let's put another 3 in that one. And then we've got 7 cubed, so that's 3 7s, so it's a 7, and another 7, but we're 7 short here, so we're going to have to put another 7 in that diagram. So that means we need to times by 3 and times by 7, so that'll be times it by 21. So that means if we times 4,116 by 21, we get a square number, and that's it. Okay, let's look at our next question. Okay, let's look at our next question, question number 28. So question number 28a says, write 576 as a product of primes. So we want to write 576 as a product of primes, so we're going to do our prime factor tree, and we know it's even, so let's take 576 and let's divide that by 2 to begin with. So how many 2's go into 5? 2, remainder 1. How many 2's go into 17? That's going to be 8, that's 16, remainder 1. And how many 2's go into 16? That's 8. So that's going to be 2 multiplied by 288. 2's prime, so let's circle it. Now let's look at 288. It's even, so we can half it, and half of 288 would be 144. 2's prime, so let's circle it. 144, I know that's 12 times 12, so 12 times 12. Neither of the 12s are prime, so that I'm going to write for it both of them, 2 times 6 and 2 times 6. 2's prime, so let's circle it. Now we've got 6. 6 is equal to 2 times 3 and 2 times 3. So that's it, we're finished. We've got all the prime numbers. Now we just need to write them in a list. So 576 is equal to, and I'm going to write them in order, 2 times 2 times 2 times 2 times 2 times 2. So 2 times 2 times 2 times 2 times 2 times 2. So 6 2's there, 1, 2, 3, 4, 5, 6, and then 2 3's, so times 3 times 3. So we've got all those numbers. Let's write it in index form. So that's 2 to the power of 1, 2, 3, 4, 5, 6. multiplied by 3 squared. So 2 to the power of 6 multiplied by 3 squared is equal to 576. And I know it's a non-calculated question, but I'm just going to check it. 2 to the power of 6 multiplied by 3 squared is equal to 576. Great. Okay, and then part B, we've been asked to hence find the square root of 576. Now, because it says hence, we're going to be using what we've just worked out. And 576, well, hopefully it's a square number, so let's do a number times a number is equal to 576. Now we know that 576 is equal to 2 times 2 times 2 times 2 times 2 times 2 times 3 times 3. That's 1, 2, 3, 4, 5, 6 2's, a 3 and a 3. Now let's share them out equally between these two circles. So that'll be a 2, a 2 and a 2, and a 2, a 2 and a 2, and then a 3 and a 3. So 2 times 2 times 2 times 3 multiplied by 2 times 2 times 2 times 3 would be equal to 576. So if we work out what 2 times 2 times 2 times 3 is, that'll tell us what this number is. So 2 times 2 is 4, times 2 is 8, times 3 is 24. So 24 multiplied by 24 is equal to 576. So that means that the square root of 576 would be equal to 24. So the answer is 24. And that's it. Okay, let's look at our next question, question number 29. So question number 29a says, write 1728 as a product of primes. That's a non-calculator question, so let's get started. 2, and it's even, so 1728 divided by 2. How many 2's going to 1? 0, remainder 1. How many 2's going to 17? That's going to be 8, remainder 1. How many 2's going to 12? That's 6. And how many 2's going to 8? That's 4. So that's 2 and 864. 2's prime, so let's circle it, and then we've got 864. That's even, so let's half it. So half of that number would be 432. 2's prime, so circle it. Now we've got 432, let's half that, so 2, and then it'll be 216. 2's prime, so let's circle it. 216, we've got 2, and half of that would be 108. 2's prime, circle it. Okay, 108, that's going to be 2 and 54. That's great. So we've now got 2, circle it. And 54, that's going to be 9 times 6. Neither of those are prime, but we've now got 3 times 3 for 9 and 2 times 3 for 6. And they're all prime. So that means that 1728 as a product of primes would be 2 times 2 times 2 times 2 times 2 times 2 times 3 times 3 times 3. So let's deal with the 2's. There's 1, 2, 3, 4, 5, 6 of them. So that's going to be 2 to the power of 6. And then 3 cubed. So times 3 cubed. So that means that the answer would be 2 to the power of 6 multiplied by 3 cubed. And that's equal to 1728. Okay, and then part B. Part B says, hence find the cube root of 1728. So because we're trying to find the cube root, that means it'll be a number multiplied by itself again. And that's going to be equal to 1728. So if we take these prime numbers and share them out equally, then we'll find out what that number is. So 2 to the power of 6, so that's 6 2's. 1, 2, 3, 4, 5, 6. So we've shared out the 2's. Now let's share out the 3's. There's 3 of them. So 1, 2, 3. So that means that 2 times 2 times 3 would be what our number is. So 2 times 2 is 4 times 3 is 12. So 12 times 12 times 12 would be equal to 1728. And that means that the cube root of 1728 would be 12. And that's it, that's our answer. Okay, and let's look at our last question. So question number 30. Question number 30 says that A is equal to 3 to the power of 3, or 3 cubed, multiplied by C, and B is equal to 3 squared times C squared times D. And we're told that the highest common factor of A and B is 99, and the lowest common multiple of A and B is 16,335. And we've been asked to find out what B is, this number here. Okay, so let's have a look at this. Well, we've got A and we've got B. Okay, so let's do a diagram to help us. So here we've got a circle for A and we've got another circle for B. Circle, I'm going to use that term loosely. So we've got A and we've got B. Okay, now here we've got the A has got 3 3's and B has got 2 3's. So let's put 2 3's in the middle, a 3 and a 3. And we've got an extra 3 on the A side. So that means that the A circle has got 3 3's and the B circle has got 2 3's. Okay, now C. Well, A's got a C and B's got 2 C's. So let's put 1 C in the middle and then an extra C on the B side. So as you can see, A's got 1 C and B's got 2 C's. And finally, B's got a D, so let's put a D on that side. And that's it. So we've put the numbers in the diagram. Now we know that the highest common factor of A and B is 99. So that means that 3 times 3 times C is equal to 99, because if you times the numbers together in the middle, you get 99. So the highest common factor. So that means that 3 times C is equal to 99. 3 times 3 is 9, so we've got 9 times c, and that's equal to 99. So that means the c would have to be 11, because if we divide by 9, we get the c is equal to 11. So that means the c is 11. So I'm actually just going to write it in blue here, just beside it, so we know that that's 11. So that's 11, and that's 11. Okay, so we're nearly there. We've found out what C is. If we find out what D is, then we can work out what B is, that number B. So let's find out what D is. Now we're told the lowest common multiple of these two numbers is 16,335. So to find the lowest common multiple, if you times all the numbers together, you'll get the lowest common multiple. So if we do 3 times 11 times 3 times 3 times 11 times D, that's going to be that number. So let's write that down. Okay, 3 times C, but C is 11, so I'm going to write 11 times 3 times 3 times C, which is 11, times D, what we're trying to find, is equal to 16,335. Okay, let's work out what this is. It's a calculator question, so that's nice. We can do 3 times 11 times 3 times 3 times 11, and that's equal to 3,267 times D, so times D is equal to 16,335. And if we divide both sides of the equation by this, 3,267, we'll get D. And if we take our 16,335 divided by 3,267, that's equal to 5. So that means that D is equal to 5. I'm just going to write that in the diagram as well. So D is equal to 5. And that means we've been asked to find out what B is. So we want to find this number. So C is 11 and D is 5. So that means that B is equal to 3 squared multiplied by 11 squared multiplied by D, which is 5, so times 5. And let's just work this out. So 3 squared multiplied by 11 squared multiplied by 5 is equal to 5,445. So that's B, 5,445, and that's it. And that's it. So in this video, we've gone through the video solutions to the Corbettmaths Practice Questions on product of primes, and also how to find the lowest common multiple and highest common factor using the product of primes. If you need any extra help on these topics, if you go to Corbettmaths and look at videos 223 and 224, there's dedicated video tutorials there on product of primes and using them to find the lowest common multiple, the LCM, and the highest common factor, the HCF. Alternatively, you can scan this QR code. But in this video, we focus on the video solutions to the practice questions. I really hope you found this video useful. If you have found it useful, please like it, and also please subscribe to the Corbettmaths YouTube channel. So thank you, cheers, bye.